Okay, so you already know about the abstraction, and most of the code given by the author of the book will be related with this abstraction. Okay. And all the codes are a kind of module. So they are modular. So that's why we need to understand those two basic object-oriented design principles, which is the modular and the abstraction. We will use many kind of abstract data types. This abstraction is to distill a system to its most fundamental parts. As I mentioned to you, in the abstraction, we are going to see what are the common properties in the trucks, car, sedan, SUV. Most of them, they have common properties. So we are going to put it into one abstract class or abstract data types. So applying the abstraction paradigm to the design of the data structures give rise to the abstract data types. When I explain to you some basic data structure later, you can see the ADT. Okay? Most of the parts will be related to the ADT. So ADT is a model of a data structure that specifies the type of the data stored and the operations supported on them, and the types of parameters of the operations. So you already know, whenever we have the class diagram, okay, we always have the class name, and then we have the data members. The data members, including the type, okay, maybe it is the integer or string or float, and the operations, which is related to the method. So ADT specifies what its operation does, but not how it does it. So it will just specify, okay, this data type need to have the for loop. This function need to check the balance. The collective set of behaviors supported by ADT is its public interface. In some code, there might be some public interface. Maybe I will focus more on the ADT rather than public interface. The encapsulation is the process of binding both attributes and methods together within a class. So you already learned, if it is a class, then there will be attributes or data types, data members with the methods. Through encapsulation, the internal details of a class can be hidden from outside. So there might be the public variable, or there can be private variable, or there can be protected variable. The class has methods that provide user interface by which the services provided by the class may be used. For now, I will use mostly public. So it will be easier to connect from one class to another class. But if it is private, yeah, of course, you cannot access. It is only in that respective class. And also when we are doing with this class, the concept of interface is more public, but in the class, you can specify whether you want to public or private or protected. And you may understand the iterators. Okay, in the previous weeks, we learned about the iteration when we use the keyword iter. When we use the word iter, we want to make the iteration until a certain stopping criteria. The iteration is an important concept in the design of the data structures. Iterators for a collection provides one key behavior. So it has a special method named next. And it returns the next element of the collection if any or raises a stop iteration exception to indicate that there are no further elements. So if we are already reaching the end of the element, then it is stop. So the stop iteration will be the message. You already know about range. So let's check how this range class works. So Python also helps by providing an automatic or iterator implementation for any class that defines both length and get item. So if you see in some ADT later on, you will see length, get item. So those two are already in Python. So you do not need to define it. So similar with the init. When you define the underbar init, it is already defined in Python. The same with this init, there will be also underbar length to indicate the length of one kind of data structure. Or you can also get the get item. So the get item is already a Python method. So you can just call it to make it as your method in your class. So in this class range, you will see there are three methods. The first is the constructor, and the second is to find the length, and the last method is to get the item. I think I give you range.py. If you take a look on this one, yeah, this is inside of the range. Yeah, if you want to run here, if you still remember when we use the range, we have like three kind of parameters: okay? Starting and stop, and then interval. Maybe let me just give you one more. For I in range, we are starting from 2 until maybe 20, and then we have 2 interval. I want to print I. So I have the starting number, which is 2, and then I have the ending number, which is 20, and then I want to have every 2 numbers. How we can make this kind of range? So this is the detail. We have the constructor, and then we need to use the self parameter, and then we have the start, stop, and step. as you can see here, stop equals to none. It means if you don't define any things, yeah, there will be a none, or it is the object will be none. And the step, the default is 1. So if you do not define anything, it will be 1. The step equals to 0, then we raise. You still remember raise? Yeah, we already learned one exception using raise. It will give a message. Step cannot be 0. If the stop is none, it is the special case of range n. So whenever you write like this, for I in range 5, then you will print until 5. Okay, you will print from 0 until 5. This is not the starting, but this is the stopping. However, you have the start, stop, and step. That's why if it is known, okay, when there is no object in the stop or in the second parameter, then we call it the stop is known. If it is known, then let start equals to 0. And let stop equals to the start. The start is this one. Okay. That's why if I put range equals to 5, then it will start from 0 until 5. Okay. And then what about the length? So the length is, we want to get the maximum. The maximum, whether it is from, yeah, we have this stop minus start plus step minus 1, and then divided by the step. Yeah, we need to define this one. When you have this parameter, of course, it will be different for every of the length. Like this one, I know that the length will be 5. But what about this one? You can calculate by hand. 1, 2, 3, 4, 5, 6, 7, 8, 9. The length is 9. But how if I just give you this number, and can we calculate the length? So this is the formula to calculate the length. Yeah, if there is nothing with the previous one, we can just make, yeah, like this one, the start equals to the start and the step equals to the step. And for the length, it will be the length you define here. And get item. So the get item means I want to iterate. I want to do the iteration after I define for every object, start, step, and stop. Here, if the k is less than 0, yeah, k is return entry at the index k. Usually we have the a number k, and if k is less than 0, then yeah, k will be added by the length of the respective input. If not k less than 0 or not higher than the length, if not, then it will be indexed out of it. So you will get the result start plus how many steps you want to do. If you have like 5, then the start will be plus 5 multiplied by step. So this is how we define with the range. So this is the automatic iterators with the range. So you can just use range. You don't need to design again. But if you want to design your algorithm like this class, yeah, you need to define the step by step like these iterators. So in a inheritance, it is a mechanism for a modular or hierarchical organization. This allows a new class to be defined based upon an existing class as the starting point. So this existing class is typically described as base class, or we have parent class, or superclass, while the newly defined class is known as the subclass, or yeah, some kind of literatures they call it child class. There are two ways in which a subclass can differentiate itself from its superclass. A subclass may specialize an existing behavior by providing a new implementation that overrides an existing method. A subclass may also extend its superclass by providing brand new methods. Maybe you have difficulties to understand this all. Okay. Maybe for the easy one is we can say superclass and we have subclass. The superclass is the higher hierarchy or the higher concept, and the lower is the subclass. The easy way to understand this one, maybe with the example, like this one, exception or the error message in Python. In Python, they have base exception. So if it is not correct, okay, there should be an error message. Okay. And what is the error message? The error message will be based on the error type, whether it is a system exit or the interruption or any other exception or the keyboard interrupt. If it is the exception, so if there is an error in your code, then there will be other kind of type, maybe value error, lookup error, or arithmetic error. If it is related with the lookup error, there will be another kind of details. It can be index error or key error. If it is about the arithmetic errors, maybe it is about the zero division error. So this is a kind of hierarchy, and we call this is the inheritance. The zero division error inherit some properties in the top. This arithmetic error inherit some properties from the top. This exception inherit some properties on top. Basically, all of them are exception or errors, but they split into more details. Let's see one example if we are doing with the student. Now I have a student class and I have 3 data members: student name, student city, and the score. So I have the student name, student city, student score, the same with the previous one. And I have one new method. I have a method to set the student score. Now I'm going to have one more class, which is graduate student. Graduate student may have different requirement. Maybe in the undergraduate students, you need to finish what 100 something credits. Back normal October. Yeah, I forgot the number. But for the graduate students, they need to finish about 30 credits. Some October, maybe 27. Yeah, I do not remember. Let's say I just put the 30 credits. So they are the same students, but the requirement different. So I want to make a new detail. The student name, yeah, the data is the same. The student city, they are the same. And the student also will get some score on the exam, on the assignment. But the detail is different because the maximum credit is different. Now we need to make this kind of class. So I will like to use this one again. Oh, I think, yeah, if you want to run this one, later you can try to run by the same idea like this one and this one. Basically, it is, yeah, I forgot to run this. Yeah, you can make it like R1, for example, range 2, 20, 2. Okay. One. So you cannot see because it is an object. And if you want to see, yep. So you can make an object R1 with the respective number, and then you can make this as an iterator, and then you put every element in one variable like I, and then you can just print. So you will get the same value with the range file in Python. Okay. Now I would like to continue this one. So we have the class student, and then this is the same with what we did before. Okay. And the other are also the same. Now I'm just adding one new class, and the class is graduate student. Okay, now we can see the graduate student. We are inheriting the properties from student. Okay, so we call this is inherit. And we have constructor, and the constructors are the same. Student name and student city. Because they have the common properties, name and the city. So I just use the class student because they are the same. Okay. That's why when we make the constructor, we call the superclass. This is what we can do. We call super. And then we want to call the constructor from the superclass. How we know that it is the superclass? Because we define it here. Okay. The graduate student class will inherit from the student class. This is the student class. If you call this is the student A, like this one, then this will be also with the same name, student A. Because I used only student, so I will just use student. Okay. Now I'm using the superclass and the same as what I explained in this constructor, I would like to have two parameters, student name and student city. And let's define the maximum credit equal to 30. And I just have one function, get maximum credit. Okay, so I can run. The same with the previous examples, we can define the S1 and S2. Okay. Let's suppose I have the S1 is, yeah, like this information, Yahya, Yongin, and Bernardo, and so on. Oh, okay, I cannot copy and paste directly. So if I have S1 and S2, like this one, I can define the S1 with, yeah, if I want to know, get the student name, then I can get Yahya, and so on. How if I want to make a graduate student? Okay, let's say Yahya has been graduated. Now he is entering the graduate school. So the name, yeah, will be the same and the city will be the same. Now I can create this one, G1. My question is, do we have the get student name in this class? We don't have. But when you call the G1 dot, you will inherit. Okay, we call this inherit. You can call all the functions from the student because the graduate student class inherit all the functions from student. So you can check the student name. Yeah, the name is Yahya. Because this is the G1 as the graduate student. So we don't need to specify the student. We just need to specify the graduate student object. Now, let's suppose I want to check the G1 get maximum credit. Okay. I want to know the maximum credit of the graduate student. Okay, the graduate student maximum credit is 30. But can I check the S2, the student maximum credit? Can I check the student maximum credit? No, because it is a separate class. So the graduate student can get all the properties from the student, but the student cannot get the properties from the graduate student. Okay? That's what we call as the inheritance. Okay? There is one more example from the book. It is about the numeric progression. The numeric progression is a sequence of numbers where each number depends on one or more of the previous number. There are three progression: arithmetic progression, geometric progression, and Fibonacci progression. The arithmetic progression is to determine the next number by adding a fixed constant to the previous value. So for example, 1, and then next is 2, and next is 3, and then next is 4, and so on. Or if we have every 5 numbers, so maybe the numbers will be, the first is 1, and the next is 6, and then next is 11, and then next is 16, and then next is 21, and so on. We want to see the numbers for every 5 starting from 1. The geometric progression is to determine the next number by multiplying the previous value by a fixed constant. So in this case, we can have the multiplication with 2. 1 multiplied by 2 is 2. 2 multiplied by 2 is 4. 4 multiplied by 2, 8. 8 multiplied by 2, 16. Multiplied by 2, 32, and so on. Fibonacci. I think you know the Fibonacci. You have numbers. Let's say we start with 1 and 1. The next number will be the addition of the previous 2 numbers. So 1 plus 1 equals to 2. The next number will be the addition of 1 plus 2, which is 3. The next number will be the addition of the previous 2 numbers. 2 plus 3 equals to 5. The next number will be the addition of the last 2 numbers. 3 plus 5, this is 8. And so on. We can make this as a class. So here is the class, okay, the progression base class. We have the base class here. And the base class will be divided into 3. The arithmetic, geometric, and Fibonacci. The idea actually is the same. It is a sequence of numbers. The difference is only the formula. One is using addition, one is using multiplication, and the other, the formula is the last 2 numbers will be added. Now you can see the progression base class like this one. This is the arithmetic, and then this is the geometric, and then this is the Fibonacci. So let's figure out this example. I give you also the progression.py. You can open it and let's see. Let me to make it easier, let's just copy and paste here. In the class progression, this is the base class. Okay? We call it the base class. In the base class, we have the init method, which is to construct, or it is the constructor. And then the start will be starting from 0. Current equals to start, because this is the initial. And then advance. Advance means, yeah, if we want to advance to the next, yeah, we will add by 1 to the current value. Next. So as I mentioned to you, in the iteration in Python, they also define the next method. The next method is if the current is known, yeah, then stop iteration. If there is no object or if there is no number at the current state, then stop. If it is not, then yeah, we are going to give the answer equals to the current value, and then let's go to the next. And then let's return the answer. We have the iteration. The iteration, by convention, an iterator must return itself as an iterator. So this one is just when you are iterating, you will return itself. And print. The print progression means we will print what we are going to show, whether it is the arithmetic or it is the Fibonacci or it is the geometric, we will print. So there's one function to print. Now we need to go to the details. In the base class, we just have very common properties. For all progression, we will have the similar properties. We are going to the next. And what is the next? We don't know. Maybe the next will be added by 1 if it is arithmetic. Maybe the next will be multiplied by a number if it is geometric, and so on. So the details will be in the every of the class. The arithmetic progression, now you can see in the parenthesis we have progression. It means it is this inherits from progression. All the properties in the progression will be in the arithmetic progression. So you have this init or the constructor. The default value is increment by 1. So if there is no definition, then the increment will be 1. And if there is no definition, the starting number will be 0. Super. We call the super class. Here we are making the starting point, and the starting point will be the same with the base class. And the increment will be as the definition here. Advance. So we are going to the next number. What is the next number? The next number will be based on the current plus by the increment. If the increment is 1, you will increase 1. If the increment is 2, you will increase 2. Okay. What is geometric progression? In the geometric progression, the default value will be base 2. And then the start will start from 1. You cannot start from 0, because if you start from 0, 0 multiplied by 2, it will be 0. So the next number will be always 0. So that's why we need to start from 1. And again, we call the superclass. So the superclass, we can construct the starting number, and then the base, we call it the base, which is the multiplier. Okay, what number we want to do the multiplication. Here we have the base 2. So for the advance, it means if I want to go to the next number, I will update it. I will not use the advance from here. I will not use plus 1 from the base, but I will use the advance from the respective geometric progression, which is multiply by the base. And what about the Fibonacci? In Fibonacci, now we have the definition. The first will be 0 and the second will be 1. After we have the default value, again, we are creating an object from the hierarchy or the superclass. We just define the first, and then we have a new variable, which is the previous. The previous will be the second minus the first. So we will have like two values. In order to know the next value, so we will define two variables, which is previous and current. And the previous will be the current value, and the current will be the previous plus the current value. Okay. So after we have this one, then we have one main method. And in this main method, we have several objects. Okay. The first we call the class progression, and I would like to print 10. The next is arithmetic progression with increment 5. So I call arithmetic progression 5, and then I would like to print for 10 numbers. This one, arithmetic progression with increment 5, start 2. So the addition will be for every 5, and the starting number is 2. Geometric progression with the default base, it means we will do with the 2 every number until 10 times. This one, I would like to change the base, not 2, but now becomes 3. So it will be multiplied with 3 for the 10 sequence number. The Fibonacci, we have also 10 numbers starting from 0 and 1. But if I want to start from 4 and 6, so after 4 and 6, we have 10. And then 6 plus 10, we have 16. And then, yeah, we will do until 10 numbers. If you run this, you will see like this result. The default progression is just a sequence from 0 until 10, because for every number we will just add by 1. When we call the arithmetic progression, we want to increase by 5. Okay? 0 and then 5 and then 10 and 15 and 20 and 25, yeah, and so on until 10 numbers. The arithmetic progression with increment 5 and start by 2, so we can have 2, 7, 12, and so on. This is the geometric progression with the default base. This is 2. This is the geometric progression with base 3. 1, 3, 9, 27, and so on. This is the Fibonacci, and the starting point is 0 and 1. And this is the Fibonacci, which is starting from 4 and 6. Okay. You can try to look at the code again to understand the whole idea of this class. Okay, we will learn about the algorithm analysis in the next class. Any questions?